In this video, we're going to talk about the first of 4 cases when we want to find a limit as x approaches a of some function f of x. And the first case is called direct substitution, and this is the easiest. So the key fact that this method is going to rely on is the following. It says that if f, our function, can be written with a single formula. And by single formula, I mean it's not piecewise. So just a single formula. In terms of known functions, so functions that we know like polynomials or absolute values, exponentials, logs, functions that we know, and a, whatever x is approaching, a is a number that's in the domain of f, then what we can do is we can simply plug in x equals a directly. Okay, so I'm going to highlight this. So we can simply plug in x equals a directly, or in other words, we can substitute a in for the x. Okay, so let's look at an example. So suppose that we have the limit as x approaches -2 of x cubed minus 8 over x minus 2. So in any limit question, we always begin by, maybe I should say, in any limit that I want to do algebraically, so not numerically, not using the graph, we always begin by plugging in. And when we do that, if the result is defined, in fact, let me put that in a different color. If the result is defined, so for example, if we're not doing stuff like dividing by 0, not dividing by 0, or taking square root of a negative, etc. Those are just a few things that can make something undefined. If the result ends up being defined, when you plug in, this is the answer. This is the limit. Okay, so let's try that here. Let's try plugging in -2 and see what we get. So if we plug in -2, we end up getting -2 cubed minus 8 on top, and in the denominator we get -2 minus 2. Okay, so overall we have -16 in the numerator, -4 in the denominator, and then dividing, we get 4. And that's our answer. So this was an easier situation because we were able to plug in and there was no issue like having an undefined expression show up. We will talk about things like that over the next few videos. All right, so in terms of our goals, we have talked about the first of 4 cases in terms of what form we could end up with after we plug in x equals a, which was if our function was a single known function and a was something in the domain, we're able to just substitute in, plug it in directly to get our answer.